another polynomial division problem up here on the board. I just want to work through this one together, and then I'll give you folks one to try on your own. So notice this is written in descending order, and so is this already. If not, I want to rearrange them before I write using long division. If it's this divided by this, the first thing goes under the division sign, so it'll be 2x cubed plus 3x squared minus 2x plus 5 here. And then x squared plus 2x plus 3 goes on the outside. So we start by just looking at the lead terms. What would I multiply x squared by to get 2x cubed? I'm thinking 2x. So I'm going to put that here. Again, it doesn't matter where I put it, but because I need to line up my work down here, I like to just always line up x's with x's. Now I multiply, and I've got to multiply the 2x by the whole thing. So 2x times x squared gives me 2x cubed. 2x times 2x gives me plus 4x squared. And 2x times 3 gives me plus 6x. Now we're ready to subtract. I want to remember that that means change the sign and add. So I'm distributing my negative here. Now the x cubes cancel out. That should always happen. I'm rigging it so that I get a perfect match here so that that drops out. And basically, that just gives me a smaller problem because now my lead term is going to be x squared instead of x cubed. 3x squared minus 4x squared is negative x squared. Negative 2x minus 6x is minus 8x. Bring down that 5. And we repeat. So we look at our lead term. What would I multiply x squared by to get negative x squared? I'm thinking a negative 1. Okay. Now there, because it was negative, I'm automatically writing that subtraction sign in between the terms. Remember, when it's positive, to explicitly write in the plus sign. All right, we multiply. Negative 1 times x squared gives me a negative x squared. Negative 1 times 2x is going to give me a negative 2x. And negative 1 times 3 is going to give me a negative 3. When we subtract, we're going to change the sign and add. So changing the sign, I've distributed my negatives. The x squareds cancel. Negative 8x plus 2x is negative 6x. 5 plus 3 is plus 8. Now at this point, that's my remainder. We're often used to remainders just being numbers. When we're working with polynomials, we hit the remainder as soon as the degree down here is smaller than the degree out here. Okay. Here, this is degree 1, because the biggest power of x that shows up is x to the first. This was degree 2. As soon as the degree is smaller, you're at your remainder. Now, if what's outside here was linear, so that it was degree 1, our remainder would have to be degree 0. It would be just a number. But if you're dividing by something that's degree 2 or higher, it's entirely possible that your remainder will have some x's in it. So what do we do with that remainder? Well, let me remind you, if we were doing something like 7 divided by 3, we'd say 3 goes in twice. That gives me 6 with 1 left over. And then we can take that and write that as 2 1/3. We take the remainder and we put it over what we were dividing by. Now here, I'm going to do the same thing, but I'm going to first of all write a plus sign. So I'm going to add negative 6x plus 8 over x squared plus 2x plus 3. Okay. Very important to write that plus sign. Here I didn't have to, but think of how we would read that number. That's 2 1/3. We have this convention for mixed numbers that if I write a fraction directly next to a whole number, it's understood that I'm adding them. That means 2 or 2 plus 1/3. We don't have that same convention for polynomials, so if I want to say I'm adding this, I have to explicitly write that I'm adding it. Okay. So if we get a non-zero remainder, we simply add the remainder over what we were dividing by. All right, I'm going to give you folks one to try before you tune in to the next video, and then we'll go over it together. I want you to take a look at x cubed plus 2x minus 3 divided by x minus 2. So remember, that's another way I can write a division problem, just writing it as a fraction. Try working that out using your long division, and then in the next video we'll go over that, and I'll show you a nice shortcut, which is called synthetic division. Just a word of caution, the synthetic division is a really nice shortcut, and it works for examples like this, but it wouldn't work for examples like this. So we'll talk about when it does and doesn't work, but be aware you are going to need to know how to do long division, because there are division problems for which the shortcut we'll cover in the next video doesn't apply.